Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2019 Time Zone 1 in May. Question number 24. Concepts relating to topic 8. Exit and basis relating to the introduction of the ionic product of water, so KW. Let's see. Which solution is basic at room temperature 25 degrees Celsius, right? So the first understanding that students should have recognized is that the meaning behind basic or so-called alkaline, right? Basic or alkaline solution, which means in our topic 8 we understand that implies that the hydroxide concentration, so that's the representative of alkaline, should be bigger or higher than the concentration of proton, so that is the representative for acid, right? So that means the representative for a base should be of a higher concentration than the representative of an acid. That makes sense, right? So this is the first meaning. And given the KW, and we should notice that KW is implying that the proton concentration times the hydroxide concentration according to the definition of the ionic product of water, KW. And given this number under room temperature is going to be 1 times 10 to the power minus 14. That means for this question, now the question is simply ideas is that for the following, please help me to work out the concentration of hydroxide and proton and see which one fulfilling the situation that the hydroxide concentration is greater than the proton concentration. If that is the case, then I would expect that solution is going to be basic. Makes sense, right? So that's why for A, they're now giving me the proton concentration to be 1 times 10 to the power minus 3. So because KW state this relationship, right? So meaning that I can find the hydroxide concentration, right? By this idea, that means proton concentration, this number times this number, which is going to be this number. So that's a 1 minus 3. So minus 3 minus 11 goes to minus 14. So that means the hydroxide concentration, which is going to be 1 times 10 to the power minus 11 mole per dm cube. Right, and obviously comparing these two values, right, simple maths, the proton is higher than the hydroxide, right? So that means in this solution, the proton concentration is bigger than the hydroxide concentration. So is this going to be an alkaline situation? No. So this is going to be acidic, right? So not our choice, right? Makes sense? Yeah. So if you look at the second choice, right? Given this time is reversed for the hydroxide concentration going to be 1 times 10 to the power minus 13. Again, we can work out the opposite, which is the proton concentration, right? So this time, minus 13, minus 1 to minus 14, right? So that's why the proton concentration in this case, which is 1 times 10 to the power negative 1 mole per dm cube, right? Again, this time, the proton concentration is going to be bigger than the hydroxide concentration. So no doubt also, this is going to be an acidic situation. Not our choice, right? Next, this is the easiest one, I think, because given that the pH is going to be 4, lower than 7, right? Lower than 7 obviously is going to be acidic, right? But we can further prove it because for pH going to be 4, so that means given the proton concentration is going to be 1 times 10 to the power negative 4 mole per dm cube. This is what we learned behind the meaning of pH, right? Because pH is defined as the negative log base 10 concentration of proton, right? And because of this negative 4, and so we can judge. So that is equivalent to saying that the hydroxide concentration is equals to 1 times 10 to the power negative 10, right? Because minus 4, minus 10, minus 14, right? Mole per dm cube. So again, so this situation implies the proton concentration is bigger than the hydroxide concentration. So that's why acidic, right? Of course, if you've confirmed that A, B, C are all acidic, the final answer goes to D. Double check it. Hydronium concentration. So hydronium simply implies this is proton, right? Because they're all equivalent. Hydronium concentration have a concentration of 1 times 10 to the power minus 13. So that implies the hydroxide concentration to be 1 times 10 to the power negative 1. Because minus 13, minus 1, minus 14 mole per dm cube. Right? So that implies this time is the hydroxide concentration greater because minus 1 greater than minus 13 greater than the proton concentration. So that's why this will be a basic situation. So the only choice to be basic is when you fulfill the condition as mentioned, right? That the hydroxide concentration is greater than the proton concentration as mentioned. So that's why it brings you to acidic situation. basic situation, sorry, basic. So that's why the answer for this question, D.